Okay, so we have two more questions. This first one, integrand is e power tan inverse x over 1 plus x square multiply by inside bracket. Here we have two inverse trigonometric functions. We have square of second inverse root 1 plus x square plus cos inverse of 1 minus x square over 1 plus x square. Now here we will be using some formulas of inverse trigonometric functions. Using formulas we can simplify these two functions. Straight away, what is cos inverse 1 minus x square over 1 plus x square? कौन सा फॉर्मूला ध्यान में आ रहा है? This is straight away 2 tan inverse x. ठीक है ना? अब चेक करो, ये 2 tan inverse x होता है. कैसे डिराइव करते हैं? We put x is equal to tan theta. So we have 1 minus tan square theta over 1 plus tan square theta, which is cos 2 theta. Cos inverse of cos 2 theta is 2 theta. Okay, not always, but for timing we have to consider 2 theta, where theta is tan inverse x. So this is 2 tan inverse x. Okay, we are given that x is greater than 0. When x is greater than 0, theta belongs to open interval 0 to pi by 2. So 2 theta belongs to open interval 0 to pi, which falls within the range of cos inverse function. Okay, so we can write cos inverse of cos 2 theta as 2 theta. हम यहाँ पे लिख सकते हैं क्योंकि x के लिए condition given है. ठीक है ना? Now second inverse root 1 plus x square is tan inverse x. If we put x is equal to tan theta, 1 plus tan square theta is secant square theta, whose square root is secant theta. Okay, because x is positive, root of secant square theta will be secant theta, and second inverse of secant theta is theta, where theta is tan inverse x. So we have here square of tan inverse. ठीक है ना? Okay, now here we have e power tan inverse x, and inside bracket we have two terms having function tan inverse x. So what we do, we put here tan inverse x is equal to t. Okay, so we have 1 over 1 plus x square dx is equal to dt. Okay, so integral I becomes e power t dx upon 1 plus x square is dt. Okay, and this is t square, this is 2t. So we have inside bracket t square plus 2t. Okay, so now we have integration of function e power t multiplied by t square plus 2t. 2t is derivative of t square, so this is e power t multiplied by t square, where t is equal to tan inverse x. ठीक है ना? So here this is very nice question. We have concepts of inverse trigonometric functions. We are using some formulas, in fact elementary formulas of inverse trigonometric functions, which help us to understand what should be the substitution. हमने tan inverse x को t रखा. ठीक है ना? Now look at this integral. We have integration of e power cot x upon sin square x multiply by inside bracket 2 log cosec x plus sin 2x. अब एक बात तुरंत ध्यान में आनी चाहिए इसको पढ़ते हुए, 1 upon sin square x जो है वो cosec square x है, and cosec square x is actually derivative of minus cot x, and definitely here substitution will be cot x is equal to t. Okay, so we put cot x is equal to t. Okay, then we have minus cosec square x dx is equal to dt. Okay, so we have I is equal to e power t dx upon sin square x, means cosec square x dx is minus dt. Okay, and inside bracket we have okay, now how can we write sin 2x in the form of function cot x? Sin 2x is 2 tan x over 1 plus tan square x. Okay, now we divide numerator and denominator by 10 square x, so we have 2 cot x over cot square x plus 1. ठीक है ना यहाँ तक? Cot x is t, so sin 2x is 2t over 1 plus t square. ठीक है? Now 2t upon 1 plus t square is derivative of log of 1 plus t square. ये जो है वो इस फंक्शन का डेरिवेटिव है ना, तो यहाँ पे डेफिनेटली हमें ये फंक्शन मिलना चाहिए. वी मस्ट गेट दिस फंक्शन हियर. वी विल गेट दैट 2 log of cosec x is log of cos square x. ठीक है, वी कैन यूज हियर property of logarithm. Now cosec square x is 1 plus cot square x and cot x is t. So we have here log of 1 plus t square. जो हमें चाहिए था वो मिल गया यहाँ पे. ठीक है. Now this is function and this is its derivative. So this is minus e power t multiplied by log of 1 plus t square plus constant c. Now in this put t is equal to cot x. ठीक है ना? So here we have some substitution techniques. Let's try one more question. Okay, now here we have a very interesting question. We have function e power x power 4 multiplied by inside bracket x plus x cube plus 2x power 5 multiplied by e power x square. Now definitely here we will use substitution technique. क्या सब्स्टिट्यूट करेंगे? We have here even powers of x, x power 4 x square and inside bracket we have odd powers of x. ये कुछ odd है, ठीक है ना, कुछ अजीब सा है. क्या कर सकते हैं? We can get x common from this bracket, so inside bracket we have 1 plus x square plus 2x power 4. This multiply by e power x square multiply by x dx, and here we have e power x power 4. Now we let x square is equal to t, so this will be dt upon 2. ठीक है ना? From this we will get 2x dx is equal to dt, so x dx will be dt upon 2. So here integral I becomes e power t square multiply by 1 plus t plus 2t square multiply by e power t multiply by x dx is dt upon 2. Okay, so we have here 1 upon 2 multiply by integration of this function. Now our aim is to write this function as e power t multiply by f of t plus f prime t. हमें इस फॉर्म में रखना है इस फंक्शन को. Then definitely we are going to multiply e power t square inside bracket, but smartly, so that we get f of t plus f prime t. कैसे मल्टीप्लाई करेंगे? We have t multiply by e power t square plus e power t square multiply by 1 plus 2t square. Okay, now purpose of writing like this is that I am assuming that if this is function f of t, then this is its derivative. थोड़ा हमें hit and try तो करना पड़ेगा. Let's take derivative of t multiplied by e power t square. We have derivative 1 multiplied by e power t square plus t multiplied by 2t multiplied by e power t square. Take e power t square common, inside bracket we get 1 plus 2t square, which is there. Okay, so this is f of t, then this is its derivative. So this is equal to 1 upon 2 multiplied by e power t multiplied by t multiplied by e power t square. Put t is equal to x square, we get 1 upon 2 multiplied by e power x square multiplied by x square multiplied by e power x power 4 plus constant c. So this is very nice question. Here we have least integration and maximum differentiation. ठीक है ना?